conditions for the formation of ionic bond. Just now we observed the formation of ionic bond between sodium and chlorine. Favorable conditions. What are the conditions favorable for the formation of ionic bond? The fundamental condition and most important condition is the electronegativity difference between the two bonded atoms to form an ionic bond their electronegativity difference must be more than 1.7. This is the main character. And other favorable conditions, if we want to discuss, the favorable conditions which are favorable, the conditions which are favorable for the formation of a cation and anion separately are favorable for the formation of an ionic bond, because in ionic bond one cation and anion is essential to form an ionic bond. So ionic bond is present in between two oppositely charged species, that is, one is positive species and other one is negative species. Positive species is said to be a cation, negative species is said to be anion. So the favorable conditions for the formation of ionic bond is nothing but the favorable conditions that are favorable for the formation of anion and cation. Let us discuss the favorable conditions. What are the favorable conditions for the formation of a cation? So favorable conditions, cation. A positive ion, cation, is formed when an atom loses one electron. So any atom can lose electron if its lost electron is least attracted by the nucleus. That means the electron which is to be removed should be leastly attracted by nucleus. Nucleus will attract all the electrons present in its atom. But this attractive force, nuclear attractive force, is more on the electrons which are closer to it. As we move away from the nucleus, nuclear attraction over the lost electron will decreases. That means atoms with large size can easily lose an electron. So to form a positive ion, atom with large size is favorable to form a cation. First one. Second one, the amount of energy that required to remove an electron from an atom is said to be ionization potential. So the atoms with low ionization potential values, obviously large size atoms will have low ionization potential. So the elements with low ionization potential can easily form a cation. Similarly, less positive cations can easily be formed by more positive cations. That means a unipositive ion can easily be formed than a dipositive. Dipositive ion can easily be formed than a tripositive. For example, if you take Na plus, Mg plus 2, Al plus 3, the less positive and sodium ion can easily be formed than magnesium, than aluminium. So less positive ions can easily form a cation. Less positive charge cations. Less positive charge cations can easily be formed. Less positive charge cations can easily be formed than high positive charge cations. So the important factors that required for the formation of a positive ion is the atom must have low ionization potential, large atomic size, and low charge on ion. Now come to the favorable conditions for the formation of anion. Favorable conditions for the formation of anions, quite opposite to this. Here, an atom can lose electron easily when it have large size. Here, to form a negative ion, it has to accept an electron. Any atom can accept electron only when its atomic size is less. So, less size atoms, less atomic size is favorable condition for the formation of an ion. Less atomic size is favorable condition. Now, to attract the electron from outside, it should have more electronegative. It should have more electronegative. So, the atom with more electronegativity can easily form an ion. Atom with small size can easily form an ion, and an atom with high electronegativity can easily form an ion. And here and in positive case and negative case, less charged ions can easily formed than more negatively charged anions. Less negatively charged anions can easily be formed than more negatively charged anions. So these are the favorable conditions for the formation of anion and cation respectively. If once the two bonded atoms will have the particular characters which we are discussed, the atom which is having large in size, low ionization potential, and having smaller charge on its cation, it can easily form a cation. Similarly, atom which is smaller in size and having high electronegativity and lower negative charge can easily be formed an ion. If such two atoms are in contact with each other, an ionic bond can easily be formed between those two atoms. So, the favorable conditions which are favorable for the formation of anion and cation separately for the two bonded atoms are the only favorable conditions for the formation of ionic bond, because formation of ionic bond will take place between two oppositely charged species, that is in between anion and cation. If once the anion and cation are formed, there is no boundary or there is no restriction for the formation of an ionic bond. So the main task in the formation of ionic bond is the formation of anion and cation. So those factors which are favorable for the formation of cation for one atom, anion for the other bonded atom, the same conditions are the favorable conditions for the formation of ionic bond. Ionic compounds. General properties of ionic compounds. Generally, ionic bond is a strong bond. It's the force of attraction which binds the oppositely charged ions is electrostatic force of attraction. So, it is a strong bond. It strongly binds the oppositely species together. Moreover, this bond is non-directional bond. That means, in NaCl crystal, each Na plus ion is surrounded by 6 Cl minus ions, one in the front and other in the back side, and each Cl minus ion is surrounded by 6 Na plus ions, like this. So each ion is surrounded by oppositely charged ions. No specific bond is formed between any two oppositely charged species, because there is a possibility of bond between these two, and this and backside also. So there is no specific bond. These attractive forces are completely arranged. That's why ionic compounds are generally, they are in solid state with high melting points. So ionic compounds are in solid state with high melting points. Next. Just now we discussed that there is no direction. This bond is non-directional bond. So it cannot exhibit or cannot show isomerism. Isomerism is a fundamental property of covalent compounds. With same molecular formula, if two or more compounds are possible to form with same molecular formula, that phenomena is known as isomerism. This isomerism is possible when the bond is directional bond. Covalent bonds are directional bonds. In a particular direction, the bond will form. But in the case of ionic bonds, since they are non-directional bonds, they cannot exhibit the isomerism. And ionic compounds, they are soluble in polar solvents, insoluble in non-polar solvents. For example, NaCl, if we take NaCl, there is a strong electrostatic force of attraction between sodium and chlorine. To convert into liquid state, you have to heat it to nearly 90 degrees centigrade, 900 degrees centigrade, then only it will melt and convert it into a molten state or liquid state. But the same NaCl, if you dissolve in water, at room temperature itself, it ionizes to give Na plus and Cl minus ions. So ionic compounds are soluble in polar solvents like water. Because in polar solvents, you will have a negatively charged end and positively charged end. For example, if you take H2O molecule, in H2O molecule, oxygen is bonded with hydrogen like this. Here you have partial negative charge, here you will have partial positive charges. So this bond, this molecule will be like this. In a center you will have negative charge and end you have positive charge. So water molecules will surround Na plus ion like this. So that negatively charged end will closer to sodium. And in the case of chlorine side, the positive end will close to chlorine like this. Because of this, the bond between sodium and chlorine will weaken and it ionizes as two separate ions. These ions are surrounded by water molecules. This is called as solvation. Grouping of or coagulation of solvent molecules around a solute ion is said to be solvation. So solvated ions will form. Here chlorine, in the case of chlorine, the same water molecules will surround chlorine like this. Positive ends towards chlorine. Because of that solvation, this ionic compound is ionizable, soluble in polar solvents. If it is a solvent, is a non-polar, the solubility is not possible. Next, since they are in ionized state, in molten state or in aqueous solutions, ionic compounds are in liquid state. In their liquid state, each ion behaves an independent unit and they move in all the directions. Because in fused state and in aqueous solutions, these ionic compounds will act as good conductors of electricity. In fused state or in solid state, they behave as a bad conductors or non-conductors. But in liquid state, that is in their molten state or in their aqueous solutions, they act as good conductors of electricity. So these are the general properties of ionic compounds.